Okay, for our 8.3 homework, I'm going to do a couple problems with you and I'm going to have you try some on your own. So remember, we're writing an algebraic expression for what does this look like in math terms. So product means times, quotient means divide. So we want the product of 7 and this. So we're going to take 7 and we're going to times it by c. 7 times c. And then it says minus 13. Now it does not want us to take it away from 13. It just says minus 13 so we can keep it at the end here. So have you try number 5. And then number 6 wants us to find the variable, the coefficient, and the constant. So a variable is our letters. Those are the things that could change, right? This b could be 5, could be 10, could be 100. We don't know what this b is. So it can vary and it can change. So our variable in this problem is b. The coefficient, co means they work together. So the b and the 4 are working together. So the 4 is the coefficient. I need 4 of this. And then the constant is just anything not attached to a variable. So our constant is 24. So go ahead and try number 7 here on your own. Okay, number 8 says Alex has X dollars per week available. She has that. That is a total. So I'm just going to go ahead and draw out what she has, X. This X could be her parents give her $20, her parents give her $50. We don't know. She just gets money, okay? She spends $3, so she's taking away $3 on lunch every weekday. Not every day of the week. Every weekday, those are like school days, Monday, Tuesday, Wednesday, Thursday, Friday. So she's doing this 5 times. Write an algebraic expression. So expressions do not have equal signs. It's just the problem. To represent how much money she has left over at the end of the week. So let's just kind of think through what's happening here. She takes her money and on Monday, she's going to spend $3. Tuesday, she's spending $3. Wednesday, $3. Thursday, $3 more are gone. And Friday, and it wants to know how much is left over. So we don't know what this is, right? But we know how much she spent. She spent 15, right? She spent $3 5 times. So just think if her parents gave her $20, what would she have left over? Right? This would be 5. If her parents gave her $25, how much would she have left over? This would be 10. If her parents only gave her $15, she wouldn't have anything left over. So we're taking this and we're taking it away from the X. Okay? So we're starting with our total, taking this away from it. So see if you can use the X, the 3, and the 5 to go ahead and write me an algebraic expression here. So try that out. Okay, the Color My Room painting company charges a fixed setup fee of $20 per job. So just for them to come set up is $20. You have to pay that, 20. Okay, but you just pay it once. Okay, and right, we have this and this. We're going to put them together. And usually means we're adding things together. This and this. So I have $20, okay, right? So they have to pay $20. And they have to pay 25 cents per square foot. And they're going to paint P square feet. They're paying so, right? If this was my laundry room, so we're trying to find how much would it cost, write an algebraic expression to find the total cost to paint the room. So if they paint this little square, it's going to cost them 25 cents. And if they paint this square, it's going to cost 25 cents. And they're doing the same thing over and over and over again. Repeated addition is multiplication. So they're taking 25 and doing it P times. We don't know how big this room is, okay? But this works for any room. So if the room was this small, we would see how many P's there are and do it by 25. If the room was this big, we'd do the same thing. How many peas? Give it to the 25. We need 25 cents for every pea. So see if you can finish this expression here. 20 plus what is going to tell me the final cost for them to paint the room. Okay, a farmer gathered eggs from his chickens. E is the total eggs they collected. He's going to give a third of the eggs, 1/3 of the eggs to his friend, right? He gave them away. They're gone, subtracted. 7 of the eggs to another friend. So 7 of them, right? They're gone. He took them away. And the rest are going to his cousin. So we're going to select all the algebraic expressions that represent the number of eggs he gives to his cousin. So we know we need to start with E. Okay. And we want to get rid of 1/3 of these eggs. So we have to take away 1/3 of, means multiply, of the eggs. And the eggs are E. I need 1/3 of the eggs. And I'm also taking away 7. And that will tell me how many are left. My total eggs. 1/3 of these. So if this was 9, I had 9 eggs total and I wanted 1/3 of these, then 1/3 of 9 is 3. So I'd give 3 away, right? Like if I did 1/3 of 9, that's 9 over 3 equals 3, okay? And minus 7. So definitely E can't be 9, but it's just helping me reason through it. I plug a number in just to think about it, but then take it back out. An algebraic expression should have a variable in it. Okay, so it looks like definitely this one here can tell us how the total is. We can also take the eggs and divide it by 3, right? Isn't that what we did? We took the eggs and divided it by 3, and we minus another 7. So both of those, but notice they start with the total. If it gives us the total, we usually start with that. Like on this one up here, it gave us the total was X, and we're doing something from the total. This one, we're trying to find the total, so we've got to get bigger, usually by adding or multiplying. Okay, and number 11, let G represent the total. So again, right, totals, we're going to start with that. That's G, total. Of hours Greg will travel on his trip across the country. So he started here. He's got to get here. So he started here at 0. The first day he went 8 miles. So when he's done, he's at 8 miles. The second day he went 9 miles. The third day he had mechanical problems and only drove 4 hours. Write an algebraic expression to represent how much time he has left. So, right, what is left over here? So this problem is very similar to this one. We have our total. We know that this happened. How much is left? So go ahead and see if you can write one to match with problem 11.